So, I am Asher Finkel. I'm Rafi or Raphael or Dr. Finkel's son. And he gave me the title of this talk is Was It Worth It? Um, and the short answer is yes, school was worth it, obviously. Well, not obviously, but for me, it was very beneficial. And I think, as touched in the previous talk, and I think something that a lot of us know is that school is an avenue for us to learn how to do things. We're not going to learn everything we need to know in school and in university, but uh, we will learn the tools to be able to get the knowledge we need. Um, but there are some things that I wish that were touched on in university uh, that were not for me, and some things that could be beneficial for instructors and curriculum architects to kind of integrate potentially. A little bit about me. I graduated with a computer engineering degree from University of Pittsburgh in 2011. Immediately after that, I started working for Siemens Metal Technologies as a systems engineer, doing automation systems for steel mills. That involved a lot of traveling around the world, going to steel mills around the world, and commissioning our automation systems for the steel mills. I did what's called level 2 automation, which means that I did my part of the system would get the business data, and then from the business data, we would, in the scheduling of the steel that we were manufacturing for that run, we would determine the set points for the machinery to try and achieve. We used a lot of neural networks and machine learning in that to get optimal set points based on live conditions of the steel mill. I got pretty disenfranchised with large corporations and traveling a lot for work. So I took a break from that, and I backpacked around Latin America for a bit and worked odd jobs while backpacking, none of which were really computer science or computer engineering related at all. After that, I came back to the States, and actually I skipped a step here, but I did cook at Dudley's restaurant downtown for about a year. And after that, I started working for a local startup company called Seiko Wave. A few of you probably know Professor Lau in electrical engineering. He is a chief technology officer for that company. We do structured light 3D scanning. And I worked in both as an engineer there. I did everything on the software side of things, for acquiring scans to converting that to 3D data, and then utilizing the 3D data both for analysis and then also composition of smaller 3D data sets into larger 3D data sets. A lot of point cloud work with that. And iterative closest point algorithms and optimizing all of that. The beginning or early this year in the spring, I transitioned to another company, local company called Bitworks, and due to certain reasons, I can't very explicitly talk about what I'm working on there, but long story short, we do veterinarian data processing. I can't really say more to that specifically yet, but that's where I currently am. But I've worked in various different types of companies, very large companies and much smaller companies, and I've done quite a varied amount of work at this point, with many different frameworks and operating systems and languages and customers. So I've gotten quite a bit of experience on different aspects of really the computer software engineering field. So I have now a bunch of suggestions and things I wish I learned in school, or paid more attention to in school maybe, or lessons I learned that maybe were provided for me, but I didn't really take to heart. These are not really solutions to the problems or issues that I came across, but things that I wish I had realized were more important. The first thing is take good notes, both in school but also after school. It is so important to keep notes of what you're currently working on. I very, very often reference the good notes I took, and then I regret that I didn't take better notes at other times. And it's a lot of repeated research if I didn't take good notes. Some jobs do require engineering journals, and it shouldn't be a burden. It should be say, oh, I have to fill out an engineering journal. It should be an opportunity to say, hey, no, I have to write down what I did, and that's so good because later when I'm doing the exact same thing in 3 months, I don't have to relearn how to do it. I already did it. I already documented the steps I took to learn how to do it and how to do it. And I find this personally very beneficial. And this was not really pressed on me at school. And I wish it was more, because my notes in classes might be good, but to translate that to my professional work would have been really beneficial to me. And as I've grown as an engineer, I've taken it upon myself to do that, but it wasn't something that was ever pressed upon me to do. Asking questions. A lot of people see asking questions as a sign of weakness. It's not. It's not at all. Asking questions means that you have the wherewithal to know that you don't know something and that you are seeking assistance, which I think is great. I love it when people ask me questions, and I encourage always people to always ask questions. And the other thing is that oftentimes, if somebody has the answer is right there, and you don't have to do the time to do the research to figure out the answer to the question. And especially in the corporate world, time is money. And if somebody can answer your question right away, then you just save the company time. And that means you just save the company money. So please don't be afraid to ask questions. Encourage people to ask questions. But there's also Google and Stack Overflow, which I think we're all very intimately aware of. And there's no shame in trying these as resources. My suggestion for using them is be specific with your query, because there could be queries that people have asked similar questions that are related to what you're asking about, but maybe not exactly. So I like to start specific and then work broader as I try and find answers with these resources. But I didn't really, as an undergrad, I understood that these existed, but maybe I didn't understand the real benefits of them quite as much as I've continued on my professional career. I still use them daily, and I know a lot of engineers are the same. Also, talking to senior devs and engineers. This goes on the asking questions and research, but learning how to talk to your, I quote unquote, superiors, but people who have more experience than you is really beneficial. Not to feel uncomfortable in these situations, and knowing how to get directly to the point and whatnot. And I think a really good practice for that is going to office hours as a student. Because going to an office hour to talk to your professor, to talk to your TAs, is a really good equivalent to how to talk to senior developers and engineers on projects that you're on. Your professors, your TAs are people with experience who know in general what you're trying to do and can help you, can assist you. And so if you encourage students to actually talk to the professors and TAs, they're getting that experience of how to talk to later on in their professional careers with senior devs and engineers. Okay, utilizing school resources. I don't think I took enough advantage of this. I think that the schools often put on lots of networking events or networking and events, and there's alumni resources, there are the professors and the TAs themselves, there's the libraries. There's lots of resources that the school has that are often underutilized by students. Let's say a student's working on a personal project or a project for an internship or a co-op. Oftentimes the answers and the resources they need are at the school, and those are available to them, and they are underutilized. And then later on, when you're looking for a job, if you didn't take advantage of the networking and all those events that exist, or the alumni, then you might have missed an opportunity for a job that was closer to what you were looking for. I don't want to say that I didn't enjoy my first job out of school, but I think if I did a better job of networking, I might have found a job that I would have stuck with for longer. Okay, design patterns in code organization. So as you can see, the first bullet point, if I was better at this, I would have better bullet points. Right? When you're starting a project, knowing how the project will be laid out and how things will be structured going forward is very beneficial. You don't have to backtrack and have what we like to call technical debt. So the more that you can organize and kind of structure things initially, the less technical debt you can have later on. And so as the project grows, then you'll be in a better position. And in school, we just often didn't do large enough projects to warrant learning that if you didn't do this initially, then you were set up to fail later on. So I think the lack of large scale projects at school, where I was responsible for the patterns and organization, made it difficult for me later on to learn how to do these things. On a similar note is how to scale up. So when you have especially when we're talking about web stuff, it's easy to do something for a one-off. It's easy to do a one-off small implementation of something, but when you start having thousands or hundreds of thousands of concurrent utilizations of whatever you're working on, it can totally change how things operate. So having scaling in mind from the beginning is quite important when working on potentially large projects. I think somebody asked a question in the chat. I'll get back to that in the Q&A, but it looks like Judy might have addressed it. And then on a similar note of design patterns in organization is how to choose the right technology and framework. Let's say you're starting a new project. You get to choose, potentially, depending on your employer, how you do it. What hardware, what software are you using? What framework? Are you going to use C++? Are you going to use Java? All of these things. And knowing how to choose what framework you're going to use is difficult. And there's never a right answer per se, but just the thought process, how to think through these things is really something that I've had to, I don't want to say struggle with, but something I've had to grapple with. Sometimes there's a new language I want to try. Let's say Golang. I think that's exciting and I've never used it before. And I think, oh, this would be a good opportunity to try this on a project. And then I start working on it and then realize that, yeah, it's cool for me to learn it, but in the end, that's not anything that anybody else on the project knows or wants to learn. And so I need it's actually worse off because now other people have to spend so much time learning Golang as opposed to something that they are already comfortable with and they can already drop in and work on. So it's a mixture of your personal experience, other people's experience. There's lots of factors that come into play of how to choose the right technology and framework. And making that decision is something that I've definitely had to learn as I've grown as an engineer. Okay, personal projects. When you're in school, you have school assignments. When you're at work, you have your work that you need to work on. Personal projects, I think, are also quite important. They equal personal growth. It's continued education that oftentimes you don't get in other places. And also allows you to start looking into things that you're interested in and that nobody's asking you to do. And I think so for your just personal growth, I think it's very important, but also I've looked at so many resumes now and the things that stick out to me the most are when people have real personal projects, especially for recent grads. I don't look at school projects. Everybody has school projects, but if they have done personal work, it means they have the initiative. They're a nerd, which I like when I'm looking at resumes. It means they actually care about what they're doing. And then it also means skill. It takes skill and wherewithal to actually do these things on your own. And because it means that you figure things out on your own. And that's so important when looking at resumes. So I highly, highly encourage people to do personal projects. And that's not something I did as much in school, and I kind of wish I did. I definitely wish I did. Okay, and more on a technical level, Git and source control. I didn't know how to do these things in school, and it was not even touched on in school, and I use it daily, and it is so important. So one, just the basics, how to use Git, what the idea of a source control is, but then also how to have branches structured when you have multiple people working on a branch or on a project, on a repository. And then on top of that, pull requests, so code review, when somebody wants to add their code to the default branch, how to look at somebody else's code and review it. So how to ask questions and on their code. And as I said, don't be afraid to ask questions, both on when you're trying to do something, but also when you look at somebody else's code, how to ask questions on why they did that. Because it makes them think again on and rationalize their methodology, but also can help you understand why somebody does something. And then for the future, if you need to do the same thing, you understand. But also corrections. Somebody made a mistake. It's good to catch that, and the pull requests are a great opportunity for that. My one suggestion for pull requests is I like small ones. If they're too large, you miss things. So you miss places to ask questions, and you miss corrections that you would have been able to make if it's too large. It's easy to gloss over a large pull request. Continuing on, database and SQL basics. I learned a little bit of this in school, but I don't think enough. A lot of this I had to teach myself. And databases are everywhere, absolutely everywhere. So I have right here, like, a basic knowledge is useful, and advanced knowledge takes experience in studying. I'm not asking people to have an advanced knowledge of these things coming out of school. And an intermediate knowledge means you know those basics, and then with the basics, you know how to Google and research to find the answers to the more intermediate questions you have. So having that basic knowledge, so then when you need to get the intermediate level knowledge, you can go forward with that. Parallel processing. Maybe that was my computer engineering versus my computer science, but yes, I learned what parallel processing was in school, but I had so few, if any, projects that actually required it for the projects while in school. So when is it beneficial to use? What does parallel processing achieve that you couldn't otherwise? And then how to utilize it. So like basic parallel for loops or asynchronous methods, threading, mutexes, concurrent methods. These things have, when time and processing power is critical for projects, parallelization becomes paramount. And it's really important to understand that. And also understand, so whatever framework you're in, what's a good way to do parallelization. So I know personally, for experience, I've used in C++, I used Intel's threaded building blocks. I think it's TBB. And learning how to utilize TBB, which is a very powerful tool, made the things that we were doing in C++ so much faster. And that's just one example. And it's not, we could have used C++'s internal methods or whatnot, but like learning how to do proper parallelization in whatever framework you're in can reap a lot of rewards. And I didn't really understand the importance of that when I was in school. Okay, syntactical sugar. This is a fun one. Modern languages do a lot for you. And in school, I learned mostly C and C++ and some Python and Java, where at least when I was in school, there was abstractions, but a lot of it was explicitly spelled out for you. When you looked at the code, you knew exactly what was going on. Recently, I've worked on C#, and there's so much that C# can do, but it does it behind the scenes. And I didn't understand what was going on. And so I look at code and I honestly just did not know what was going on. And that's because of this, this magic, as we like to call it at work. So understanding the magic of your more modern languages helps you understand the language more and helps you understand what you're doing. It's really beneficial to always understand whatever language and framework you're in. The more you understand that, the better you'll be able to produce within that language and framework. So especially for these modern languages, I find it so beneficial to really learn what's being abstracted and learn how that's being done so that you can better utilize that magic itself. The cloud. It's, this buzzword that's come up in the last, I don't want to say decade, I don't know how long. Sense of time is always weird, especially these days. But learning basics with the cloud is more than just being able to make a website with HTTP and a PHP backend. That's what I learned back in the day. But learning how to do modern cloud and web infrastructure is really important. And even if you just learn basics using Azure or AWS or whatever, just learning what the different parts of these systems are and how to use the little parts for what you need, I found is really beneficial because inevitably, as software engineers progress in this modern world and this modern corporate environment, you're so likely to fall into a job that you just have to use these systems. And there's a learning curve for sure. There's a large learning curve, I think that's the right term, where you have a lot to learn before you can be productive. And I knew none of this coming into to these professional workplaces when it came to the cloud. I just had no exposure to it in school. I knew it existed. I knew the ideas behind what it would have to do and what needed to go on, but I just didn't actually, I had to learn everything myself when it came to actually to utilizing the cloud. So I really wish that I had a better understanding of that going into my, at least especially my current work. Okay, this is just a proposition. I think that this would be really cool for professors. So if a professor needs a new class idea, I think that learning things quickly is important. So we learn how to learn things in school, as we've touched on, but how to do it quickly. So I like the idea of, what if you had a class that had the exact same project, you're trying to accomplish the same thing, but you do it in a totally different way. So you have 2 weeks to do it, and every 2 weeks you start fresh and you have to do it in a totally different way. Maybe that already exists, and I'm just repeating something that you all already know, but I think this would be really cool, because this would teach people how to, one, the exposure to lots of different frameworks, but also to learn how to do things quickly. So that's just a little idea I had that might kind of help with a lot of the things that I touched on in the presentation. I think that's it. So those are, I know it's a lot of different things. And it's a lot of things that I, at this point, have had to figure out for myself, and I'm still figuring out as a professional engineer. But yeah, so that's kind of what I have. Any questions? I see, I'm just reading the chat right now. Let's see. Okay, so I see Judy asked, how do research projects compare to personal projects in a resume? That's a really good question. I'm all about research projects too. Research projects are often ones that are prescribed by the school. So something that I don't take away from a research project when I'm reading a resume is the initiative. It doesn't take initiative to do a research project, because that's something you probably had to do anyways. But that's the only harp on a research project. Research projects are often do some really interesting work, and they often take a lot of skill to accomplish. So it's not that I just disregard them, but I do see, for me, the real benefit from our personal project is the initiative that it takes to do it, to say, hey, this is something I want to do. I'm going to take my own personal time to execute. And that I see is really beneficial and important in applicants for work. Any other questions?
Yeah, I'd like to ask, you've been exposed now to lots of different platforms. Do you have any favorites or any anti-favorites of places, platforms on which to work? Operating systems, languages, libraries?
I think in general, there's definitely exceptions, but in general, most things can do most things. I think the one thing that sticks out to me just is that I worked on a system where there was a database that there was a lot of information stored for a steel mill, and unfortunately there was no kind of API layer on top of the database. There's no backend that utilized the database. All of the work for that entire project was done using Oracle PLSQL. So everything for that entire architecture was done using database procedures, which, if anybody's worked in databases, can get very ugly very quickly. There is no C++ or .NET interfacing with the database. It was all done from the database. And then there was this tiny C#, I believe, graphical interface on top of all the backend that was being done by the Oracle PLSQL. And that was a gross mess. I really did not enjoy that. That was something that should not have been done that way, but I stepped into a project that already existed. So that's one thing I didn't like. I don't like doing large projects where all the logic is being done in SQL. Other than that, I've found that usually the framework I'm in is good. If you're in C++, I've really enjoyed using Qt's framework on top of C++. I think it's a really nice way to use C++. But that's also just, I was forced into a project that utilized Qt, and I became quite familiar and intimate with it in an enjoyable way. So I guess that's what I liked and what I really didn't like. Anybody else?
Well, I'll have another question then. Can you
Yeah.
say anything about working in a corporate environment where you need to deal with projects that are already in progress? You've got to deal with superiors. So there's the interpersonal, and you've got to deal with learning new things. It's a big question, actually. How do you manage in a new job?
Yeah, the butterflies and uncomfortableness. I think, I mean, I usually start by trying to do my best to look at what's already been done in that project. Take some time to look through repositories and look through the work that's already been done, ask questions, try and get an idea of the workflow, the data flow of whatever's going on. But as I said, ask questions. If people aren't willing to answer questions that a new employee asks, then I'm not sure I want to work at that place personally. Because it already, if people are just avoiding questions, then it's not a productive work environment. So it's really about immediately familiarizing yourself with what's going on, and it can be hard. Oftentimes, the beginning of a job is either you're lost, you have nothing to work on, and they're like, just sit here and figure things out, or they immediately throw you into a project. And if they throw you into a project, that's great, because you immediately have something to start working on, and it can be slow going at first. And as you figure things out, and you change because you realize that you didn't understand exactly what you needed to do. And that's depending on the company and how well they have things defined and structured. But yeah, ask questions, learn what's going on. I don't know if that's a great answer, but it's an answer. Okay, well, unless there's any more questions, I actually do have to jump off. I realize I didn't provide my contact information, so you can write it down right now. It's asherf@gmail.com if you want to ask me more questions later on, or you can ask my father, Raphael, and he can put you in touch with me. Thank you all very much for your time and for coming to this talk. Hope you all have a good afternoon.
Thanks very much.
Take care.
So if you can stop sharing, then we can see each other again.
Maybe I can do that. Let's find out.